Right, good morning again, everybody. We are starting session 2 of our online open day. If you've been with us for session 1, thanks for staying. If you are joining us now, thank you for joining us in these interesting times when we've moved online, and we're glad to have you here. This has also been live streamed on Facebook if you have friends who want to watch there and haven't registered. The session has also been recorded and will be on our Open Day website after the event. Please visit our website. We've got some wonderful resources, videos on different career options, assessment tests, brochures, funding information, application information. In terms of the webinar, just to remind you, you're very welcome to ask questions. But please do it on the Q&A button at the bottom middle of your screen, not on the chat, because it's difficult for the panelists to find your questions in the chat, but it's quite easy to find it in the Q&A. If you wish to ask a question in Zulu, that's fine. We have a Zulu speaker who can respond to you. So with that, I'm going to hand over to Dr. Tanja Reinhardt, who is the coordinator of the UKZN Science Centre, STEC at UKZN, who will talk about careers and study options. Tanja, over to you.
Good morning, Sally. Good morning, everybody. And I hope everybody is fine on this brilliant day today. Okay, so some of you already probably know what they want to do, but some of you might not know. So I'm going to talk a little bit about the career options in the College of Agriculture, Engineering and Science. As you're aware, and Tracy already told you about that, our college consists of 5 different schools: the School of Engineering, the School of Chemistry and Physics, School of Mathematics, Statistics and Computer Science, the School of Agriculture, Earth and Environmental Science, and the School of Life Sciences. Now, behind these different schools, there's a huge variety of different, what we call disciplines, so subjects that you can study. And I'm going to introduce you to some of them. I can't unfortunately go through all of them because otherwise you're going to sit here till tomorrow, and I'm pretty sure you don't really want to do that. Okay, so we're going to start off with School of Engineering. So what we have here is civil engineering, and the civil engineers is usually concerned with the improvement of the quality of life and people and the environment. So what they basically do is they plan, design, and construct structures. And here you can see one of these very fantastic structures. So this is your Moses Mabhida Stadium. And we often get the question, you know, what is actually the difference between an architect and a civil engineer? So civil engineers or architects design these pretty buildings, and civil engineers make sure that they don't collapse. So then we have a subject that is called land surveying or geomatics. And these ones are the people that answer the question where. So land surveyors maybe get the information from satellites, so your GPS and so on, and from something that's called undersea echosonics. So if they want to map the ocean floor, so they drag a device behind it that sends out a signal and it rebounces back, and then you can see if your ocean floor is flat or it's got mountains and valleys underneath. And what they try to do is they try to build the picture of the world around us. And you might have seen this very strange looking yellow device here, maybe on the side of the road. So they also tell you or tell engineers or construction companies where to exactly build their roads, build their buildings, and so on. Then another subject is agricultural or bioresource engineers, and they use technology to connect the living world of plants, soil, water, and animals with engineering. So, for example, they develop technologies to grow and make use of sustainable resources of energy. So, for example, biofuels. Or here you can see we've got an irrigation system. So they might design irrigation systems specific for specific areas for specific types of plants. Or they design machinery, for example, for picking grapes, which requires special technology. Then we have our chemical engineers. And again, they design, construct, operate, and manage industrial plants. So in these industrial plants, what you basically do is you take raw material and you physically or chemically change it. And here you can see, for example, this is the background of the Sessel plant in Sesselberg, where they basically take crude oil, so your raw oil, and convert it into petroleum products. So things like your diesel, your petrol, and so forth. Electrical engineers, again, deal with the critical industry of how to generate electricity and how to transmit this electricity across. And there we have two sectors. We have the high voltage area, and here you can see an example of a substation. So you might design things like substations, the best way to do the transformation from high voltage to usable low voltage. Or you're going to go into the low voltage area and maybe look into optimizing appliances and make them, use less electricity. So, and when you look sometimes on your appliances, you see the various different energy efficiency labels. So, for example, an A++++ means it's very, very energy efficient. Or think about your light bulbs. So you have light bulbs. Remember the incandescent light bulbs that use lots of electricity. And now we have LEDs that use very little electricity. Then we have electronic engineers. And this includes all aspects of telecommunication. So the design of microcomputer system, signal and image processing, electronic hardware design, and many other related activities. And when you look at it, think about, I'm pretty sure some of you don't really know what signal and image processing means. Think about your cell phone. And what you do with your cell phones, of course, you take selfies. Okay, so you take selfies, and what you do with it, you send it to your friend. But how does it work? How can I take a picture here, for example, here in Cape Town, and I can send it to my friend in Durban? So that's very difficult to find out. And this is one of the aspects of the electronic engineers. And then we have computer engineers, and these are involved in many hardware and software aspects of computing. So the design of individual microprocessors. So basically those ones are the parts that determine the speed of your computer. Your different PCs, supercomputers. So these are very powerful computers that have very big computing capabilities. Things that, for example, NASA will use to launch a rocket into space. And down to circuit design. If you've never seen an electronic circuit, just do one thing, drop your cell phone, crack it open, and look inside. And you will see a little green plastic board, and that is basically an electronic circuit. And no, and we won't reimburse you for a new cell phone, sorry guys. And then we have mechanical engineers. Again, they're concerned with design, planning, and development of machines and equipment. And these machines and equipment, if you imagine, and if you've ever flown on an airplane, you've seen these very big jet engines, but they don't stop there. They also go small. Things like dentist drill that you use in medicine or surgery. Think about car motors or car engines for, let's say, Porsche or Mercedes. And I know that I've read that now the new VW is coming here to South Africa and it's going to be built in South Africa. Think about this. Then we have the School of Chemistry and Physics. So chemistry is basically the study of atoms and molecules and how they react and interact with one another and with the environment. So what do chemists do? They analyze, create, or synthesize, for example, new substances. And when we talk about new substances, and I can basically talk the whole day just about what you can do in chemistry. So think about new drugs. And I'm not talking about the happy-making drugs, okay, that end you up in jail, but I'm talking about drugs against specific diseases. Or think about the food industry. Sometimes you drink things like your, cream soda. So, and you will find out that the green color actually comes not from natural ingredients, but from chemical ingredients or artificial chemicals. Or think about the flavors. Vanilla flavor is basically usually, in order to make it cheap, is a chemical that you make in the lab and it's not been picked up by somebody. Then we have physics. So physicists want to know everything. They study the natural world from things that are smaller than atoms, so things that they call quarks and Higgs bosons and so on, or photons. And they go out into the large galaxies where they explore black holes, star clusters, supernovas and things like this. They also do, of course, and that's what you know probably from your school days, they do experiments to discover the laws of nature. This can be very simple. This can be just like throwing an apple in the air and watch what's happening when it comes down. But it can also be some more sophisticated experiments where you study individual photons and see if you can put them in two places at the same time. They also study what things are made of and how things behave. Then we have the School of Mathematics, Statistics and Computer Science. And yes, ladies and gentlemen, you can study mathematics. And I can see some of you, I mean, I can visualize some of you, you know, when they look on the picture on the left, that they kind of get this like, oh God, mathematics, oh, it's so complicated. Mathematics is a different kind of language. And they are very important people, the mathematicians. They use theories and techniques such as mathematic modeling, so computer and computer models, to try and formulate and solve practical problems. And these practical problems can be in business, government, it can be engineering problems, it can be problems that physicists have, that life sciences have, that social sciences have. So where you can't do, for example, an experiment, or you can't wait for 100 years to look at the outcome. Think about your weather forecast, which is a hugely complicated mathematical model. Or think about, nowadays is a big thing about the coronavirus. So mathematic model helps them to see if we really flatten the curve and so forth. We have statistics, which is another form of mathematics. And this is a mathematical science that is concerned with collecting, analyzing, interpreting, and presenting of data. And you have most likely seen lots of these statistics about the coronavirus again on the news, but there are lots of other things. Think about a couple of years back, there were sensors knocking on the doors, collecting all the data about, you know, families and what kind of education they have and so on. And this basically helps governments to make decisions. Statisticians also provide a guidance and determine what information is reliable. By looking at specific data, they can see, okay, so this information is very reliable because we have lots and lots of data. This information is not so reliable because we have very little data. And of course, we have computer science. And this is, of course, the science of using computers to solve problems. So this can be, for example, the design of software. So whenever you switch on your cell phone, you're using software. So operating systems like your Android. Whenever you switch on a computer, you're using software like operating systems like your Apple software or your Windows software. You can design games that you see here running on the screen. You can design special effects for the film industry. Design software to best pack ships in container ships and find actually the parcels that have to be unloaded first. Then we have the biggest school in our college, the School of Agriculture, Earth and Environmental Sciences. So we have geography that looks at how we as humans affect and are affected by the Earth and its natural system. So we study the lands, the features, those things like mountains, rivers, lakes, oceans, the inhabitants. We look at the cultural background, the different cultures, and the phenomena of the Earth. You've probably heard about global warming. You might have heard about phenomena like cyclones, typhoons, El Nino, and other features. Or you look into, for example, the effect of tsunamis on the inhabitants of the earth. Yes, you can also study the soil of the earth. There's this tiny little crust that you see outside, or basically that you see. And this is basically soil science is a study of soils in the environment. So what a soil scientist does, he gathers and interprets and evaluates information about the chemistry, biology, physics, and the fertility of soils. So if you as a farmer want to know if you can plant, for example, a specific crop, soil scientists can analyze your soil and can say, okay, so you can plant it there, or you might need some additional nutrients and so on. Then we have the study of water, or the water cycle, so which is hydrology. And what hydrologists do is they use computer models and field experiments to assess the hydrological state of the landscape. And we currently had a water crisis down in Cape Town. So they would basically gather information to help with water resource decision making. So do we have to get additional water from somewhere else? Do we have to find more water resources? They also would look into the quality of water. Is it drinking water? Where does the water come from? Where does it go to? And hydrologists basically seek appropriate solutions to the global water issues. And then we have, that's my specialty, geology, which is a multidisciplinary science. So you study the physical and chemical aspects of the earth. So things like rocks, minerals. You look at surface processes, and here you can see some surface processes here. A volcano, the composition of the earth, the structure, the origin. You look at rocks and minerals. You look at, for example, fossils, find fossils and determine what kind of life forms there was once. You look for valuable resources and minerals. And here you can see these ones are, for example, diamonds. You can look for copper. You can look for iron and so on, which are very important for the economy. Oh, here we have KFC, which is basically represents a little bit the aspect of animal science. So animal science is basically something about the animal production and animal products. So what you would look into, for example, the various livestock, investigate the health, how to breed animals, the physiology. So for example, your KFC chicken will look different to your egg-laying chicken. What do you have to feed these animals so that they grow up healthy? Environmental factors. So maybe a cow gives more milk when you play classical music, or a pig gets fatter when you, I don't know, stroke them every day. So I'm just making this up, by the way, to optimize production. What is animal science is horticulture for animals is horticultural science for plants. So it's basically the science of plant production, and they have a special interest in fruit, vegetables, flowers, and, for example, landscaping. So they will find out the best way to grow specific types of fruit or vegetables. Also, they look into the best way to pick them. So to how they can survive a little bit longer when you ship them off to, for example, other countries. Then we have plant pathologists, and they are involved in, for example, lots of different research areas. And when you look at these apples, I'm pretty sure that you don't really want to eat one of those ones. So they would look at these kinds of things and find out what caused, for example, the brown spots on the apples, or why this apple looked funny. And they will basically look for treatments. So they would, for example, look for good viruses that kill dangerous bacteria. They would look if, you find specific types of, if there's a specific type of pest, how you can get rid of these pests. Isn't that nice? I'm pretty sure now you would love a glass of Coke, oh, juicy hamburger, Yummy chips, yes. But a dietitian or a human nutritionist or a nutrition expert will say, if you're going to eat this every day, not a good idea. So you should rather look into eat lots of fruit and vegetables. So nutrition experts basically play a very critical role in modern medicine and public and private healthcare. So you serve, so they would basically look into what you can eat and what you can't eat when you have a specific ailment. So for example, if half of your stomach is removed, what you can eat, or if you suffer from a diabetes. So they would probably tell you reduce the sugar and do this and do that. So very important aspects that you will have to look into. Last school for today is the School of Life Sciences. And can I introduce you to Bruno? Bruno is a fish, and he basically represents, for example, marine biology. So what do biologists do? They study living organisms and basically look at how they interact with the environment. So they would look into, and I'll take Bruno as an example. Does he live on the ocean floor? What does he eat? Does he get eaten by somebody? Does he have any social behavior? So lots and lots of different aspects, but you don't stop at marine life. You look into insects, you look into mammals, you look into plants. How do specific plants, or which type do specific plants grow? How can you preserve specific plants? So lots of different aspects that you do when you do biology. Then we have genetics, and this is basically the study of the genetic composition of living organisms. So they look at the DNA of living organisms. And what they try to do is they try to explain how this information, how the genetic information is transmitted from one cell to another, from one generation to another. Think about cancer. Why does cancer grow? How does cancer grow? And if we understand how this happens, we can basically find maybe at one day a cure to stop, or to treat cancer. Think about how we can convict, of course, crimes or murderers or thieves or whatever by using DNA fingerprinting, by looking at the genetic information. Then we have biochemistry, and that is the study of the chemical composition of living cells. So what biochemists do is they examine the chemical and physical processes of cell and organisms. So for example, inside your body are currently biochemical processing happening when you eat food. So how does your body react to this food? So, and there are some biochemical processes happening inside. When you fall in love, when you see somebody gorgeous walking past, so you get maybe some accelerated heartbeats, sweaty palms, and so on. Again, biochemical processes happening inside your body. Microbiologist. This is a scientist who studies organisms that are very small and that are not visible through the naked eye. And this is not a coronavirus. I thought, you should know, you've probably seen enough photos of coronaviruses. So I thought I'm going to show you another virus. This is an HIV virus. So also a very big problem here. So these organisms that what microbiologists investigate can be the form of bacteria, viruses, algae, or fungi. Where would you work as a microbiologist? Think about food production. So look into, for example, making of cheese. You use actually microorganisms. You use fungi to make, for example, cheese. Think about, making bread or making yeast. Again, you have specific types of fungi that are up in that you use to do your yeast. Think about beer production. Not that you know anything about beer, okay? So alcohol. You also use microbiology to basically institute or basically get the process going. Okay, you've probably, if you've attended the first session, you've probably heard about all the entrance requirements. I just want to recap some of them. So if you want to study, for example, microbiology, biology, environmental science, marine biology, dietetics, agricultural science, geology, you would need mathematics at level 4. So that means you have to pass mathematics as a minimum entrance requirements. Remember, minimum entrance requirements between 50 to 59%. Life sciences or physical sciences or agricultural sciences at level 4, again 50 to 59%. English at level 4. Life orientation at level 4. And you need 3 other subjects from the approved list with a minimum of 28 points. But we have to exclude the points from life orientation. Sorry, guys, if you're very good at life orientation, it doesn't count. If you want to study physics, computer science, mathematics, statistics, you need mathematics at level 5. And chemistry is actually the same entrance requirements, not like here, but you need level 4 for chemistry. Mathematics level 4 for chemistry. You need life sciences or physical sciences or agricultural sciences at level 4. English at level 4. Life orientation at level 4. And you need 30 points. Last but not least, if you want to study in any engineering subject, you need mathematics at level 6. So you have to pass between 70 and 79% minimum. Physical sciences, and please note, no life sciences or whatever. Physical sciences is very important, level 6. English level 4, life orientation level 4, 33 points, and that excludes your points from life orientation. Okay, so this was basically the part that I was talking about, entrance requirements and career options. And I thought I'm just going to show you a little bit of science because, now you can just kind of relax a little bit. And I have a challenge for you. So what I've got here, as you can see, I've got a glass. Okay, I've got a glass. And in this glass, and Sally, if you can just mute your, oops. I have you on the screen, Sally. Can you just switch off your video, please? Okay, so I've got this glass here. And what I'm going to do is I'm going to fill it with water. As you can see, right? So I'm going to fill it with water. Okay. And now one of the parts that we need to do is, we want to turn this glass upside down and let these toothpicks float inside this glass while this glass is turned upside down. Possible? Not possible? We'll see. So good to know your science. So as you can see, this net, and I'll just pour it out, really has some holes. So if I turn it upside down like this, as you can imagine, the water will come out. So this is when you need this, a lid. And you can't see the lid because it's blue, just like my background. So if I'm going to turn it like this. So this is a lid, just an ordinary plastic lid that I got to place on top. Okay. And what I can do now is, with my finger on the lid, I can turn it upside down. And you can see some of the water is coming out, but there's still, lots of water inside. So what's going to happen if I'm going to reduce my hand? Make your guess. Is it going to fall off the lid or not? Is it going to stay? So we'll try it out. I thought it's going to fall off. No, it's going to stay. Why is that? What we created, and there are basically 2 different aspects that play to this. So what we created is a slight lower air pressure inside our glass. Because what happens was that the lid kind of sagged slightly and created a slightly lower air pressure inside. So now we have all this outside air pressure that pushes the lid in place and keeps it in place. And this air pressure not only comes from the top, but it comes from all sides. Secondly, we also have water in there, and water has a fantastic ability called surface tension. So what it basically does, it kind of acts like a glue, and it keeps the lid also in place. And if you've ever want to try it out, if you're going to add a few drops of water on some plastic sheet and you're going to put it flat on the surface and you try to peel it off, it's more difficult as if you have a dry plastic sheet. So what I'm going to do now is I'm trying to remove this plastic lid, and I'm going to do this by sliding it sideways, just like this. Here we go. So by sliding it sideways, you can see no water is coming out. Why is that? Because of the surface tension. And now I'm carefully going to grab my toothpicks. And what I can now do is I can now insert my toothpicks into the glass, and I hope that you've seen it. They start basically floating on top. There we go. Just like this. Okay. And as you can see, as soon as I turn my glass sideways, the water empties out. And what basically happens is that the water, because of the surface tension, the water actually forms a very thin barrier that prevents the water from coming out. But if you tilt it a little bit, it breaks open the surface tension and the water will come out. Okay, so that was it for me. I'm going to hand over to Karuna, who's going to tell you a little bit more about aptitude tests. So which might help you to decide basically on what kind of careers are more suitable for you or not. Karuna, can I hand over to you, please?
Good morning, learners. Thank you, Tanja. Welcome to UKZN, learners. Today, we're going to be looking at an assessment tool which is globally used and is fairly easy to use. Usually, if you were sitting with me, we would do it manually and you would score this test yourself. Now, what the KAES temperament sorter actually does is help you identify your personality traits or your personality type. The KTS, as it's known, is concentrates on 4 major domains which dictate and become motivation for your career choices moving forward. But these are further divided into 16 archetypes or personality types. So what it does is it focuses on your levels of extroversion versus introversion, whether you're thinking or feeling, sensing or judging, intuitive, and it measures these and gives you a score, which helps you determine where you actually fit in. Now, what we've done for you is created a little informative video, as well as worked out for you, according to the personality types, a few degrees and prescriptions that we make. So I'm going to be sharing screens with you today, and the first one would be a video. I encourage that you listen to it carefully, and as we go through the 4 temperaments, see what resonates well with you. You may think, that sounds like me. That's a good start in identifying what your traits are. So here we go with the first video. Hello learners, welcome to UKZN. Today you'll be learning about the KAES temperament sorter, and hopefully by the end of this session, you'll have some understanding as to what your temperament is. David KAES created the model of 4 temperaments. This work is an extension of work that was previously done by Carl Jung and Myers-Briggs. Your individual temperament is a combination of the following: your personality traits, such as patterns of communication, habits, values, and talents. It also involves your personal needs, your contribution to work, and the role that you play in society. According to KAES, the 4 temperaments are the artisan, the guardian, the idealist, and the rational. Let's start with the artisan. The keywords that best describe the artisan are bold, daring, optimistic, playful, and persuasive. Artisans tend to excel in arts, whether fine arts or performing arts, and they would usually find themselves in areas of social service or civil service. They are action-orientated and have a constant need for stimulating activities or projects. They are brave and love adventure. Co-workers find them charming, as artisans are blessed with serious willpower and never fail to seize the day. Next, we have the guardians. Keywords that best describe the guardian are factual, dependable, cautious, dutiful, law-abiding, traditional, and humble. Guardians work best when managing goods and services, and they always strive to ensure that things run smoothly within their families, schools, and greater society. They are responsible, disciplined, and prefer to follow the system and its rules. They have a genuine respect for authority and keep traditions alive to maintain stability. Guardians have a keen eye for detail and are not big on risk-taking. Their cautious ways often leaves little room for error, which makes them highly dependable. Guardians are building blocks in any organization, offering safety, structure, and stability within it. Then we have the idealist. Keywords that best describe the idealist are imaginative, intuitive, authentic, diplomatic, kind-hearted, romantic, and empathetic. Idealists are passionate about personal growth. They strive to discover who they are. They're extremely passionate about helping others and are naturally drawn to people. Their involvement is usually in education, social services, or journalism. Idealists make inspiring leaders or motivational speakers. They are cooperative by nature and prefer that everyone gets along. Idealists make excellent writers and artists because of their romantic imaginations and their desire to delve into the unknown. Spiritual, dreamy, and trusting, they are ruled by the heart. Lastly, we have the rational. Keywords that best describe the rational are calm, independent, logical, curious, innovative, strategic, and pragmatic. Rationals are skilled at problem solving and understanding complex systems. They are exceptionally analytical by nature and enjoy finding solutions that can be applied to real life. Whether they work within social systems like government, mechanical systems like engineering and logistics, or organic systems like wildlife and environment, rationals strive for maximum efficiency. They have little regard for authority and dislike procedures that waste time and resources. They are fiercely independent, logical, and possess serious willpower. Others might find them distant and aloof, but they are just focusing on the next project. Rationals are forward-thinking, and their innovations have shaped the world by developing the latest technology and gadgets. We hope that you were able to identify your temperament with the aid of this video. We invite you to take the test and make a note of your temperament type. Your result will appear as 4 alphabets. For example, it might be ISFP. Please make a note of this and refer to the UKZN website for more information on your temperament type. You are welcome to contact me on mahadave@ukzn.ac.za for further assistance. We wish you the very best with your upcoming exams and hope to see you at UKZN in 2021. Be very safe and healthy. Thank you, Linus, for watching that. We hope that you have maybe 2% more clarity on which of the major domains you sit in. My next share will be where you can take this exciting test, because I'm sure you're curious to know about it. And you are going to watch carefully as I give you a few instructions on how to take this test. So what we have here is the UKZN Open Day page. You can go to choose a career path, and this is where you will notice your KZN temperament sorter the video that you've just watched, and voila, take the test. If you right-click on this and open this into another window, you will note that the test comes up. There are 70 questions in this. Students, we advise that you answer on impulse. This should not take you more than 15 or 20 minutes, but it's not a timed measure, so you're not faulted for taking a little longer. If you don't understand a concept or understand a question, you're welcome to ask your parents maybe, or even Google what a certain word means for its definition. You will answer as per your gut feeling, if I may say. We say on impulse. So don't overthink it too much. Once you take the test, the 70 questions, it's tick as you go along, you will arrive at a score. So what this program is doing is actually calculating for you using your traits: extroversion, introversion, sensing, intuitive, thinking, feeling, judging, and perceptive. So once you've taken the test, your scores will appear here, and this will summarize for you what your personality type is. Please make a note of it. Make a note of it. Once you close the page, it'll be gone forever, and you'll have to take the test again. So once you have those results, we go back to the UKZN page, and you have all of your major domains here, further broken down into the 16 personality types that I first spoke about. So assuming that you are a promoter, you will get some sort of prescription from us at UKZN as to what types of degrees we are offering you that might work well with this personality type. Now, students, you don't need to agree with us. If you want to do anything else and you find that we have not said that you could, you're welcome to do whatever it is that you want to do, provided that you meet the entrance requirements, you have the skill, the interest, and the passion for doing what you need to be doing. Should you decide that this test is not comprehensive enough and you'd like a more detailed test, you're welcome to contact the student counselors on campus. Psychologists will give you a test called the Genesis, which is quite detailed. If you're not happy with the temperament sorter, you need to contact Shelley Barnsley, who's the campus psychologist, who can arrange some kind of meeting with you to take the test. And that wraps it up for me. If you have any questions, please refer those questions to either Dr. Tanja Reinhardt or Dr. Sally Frost, and we'll be happy to answer those for you. So, Tanja, it's back to you.
Thanks. It's actually back to me, Karuna. We've come to the end of the formal presentation, but we have a panel here to answer questions. So could all the panelists for session 2 please turn on their cameras and keep themselves muted so that we can see you all. Just the panelists for session 2. So that should be Tanja, Karuna, Tracy, Mbongatseni, Sam, and Swasti. If you have any questions you want to ask, please keep on posing them in the Q&A. But we've been going through your questions, and I have a general idea of the main questions. So I'm going to pose these, and Tracy, they mainly directed your way. So if you can unmute yourself, we've had a lot of questions about applications. So maybe if you can just explain to people when they should apply and how they should apply.
Okay, thank you, Sally. CAO is open for applications now, so students can go online to the CAO website and start doing their applications now. We are currently making conditional offers to the very high pointers. They will receive an SMS from us, and it will notify them on how to accept their offers. and what needs to be done therefore. So if they click on the link, they will get all questions are answered there as well.
Okay. And if some people have been concerned, if their grade 11 results are not so good, and you're making conditional offers now on grade 11 results, what can they do? Is there still hope for them?
Yes, Sally, there is hope for them. They will be evaluated on their final matric results. So when the NSC results are released in 2021, we will re-look at the matric results. And students will meet the point requirement up to the point we've reached for that matter at that time. They will be offered a space.
Okay. And I know this is a difficult question for you to answer, but with the uncertainty of matric exams when they're going to be, what is your advice to learners in matric now?
Don't stress. We are going to look at all matric results when they are released. We will evaluate you on your matric results. So whenever that is, our sessional dates are adjusted accordingly to accommodate students when their results are finally out.
Okay. Those are the main questions. Are there any panelists who want to say something? If you do, raise your hand. If not, I think that brings us to the end of this session. So thank you very much, panelists. To my audience, who I can't see, it's a novel experience talking to people who you can't see, but I hope you're out there. We launched a poll earlier. If you haven't done our poll, please will you fill it in, because we value your feedback. And then our next session starts at 11 o'clock. That is for people who are interested in degrees in the School of Agricultural, Earth and Environmental Sciences. So we will take a short break while we get our next panel up and ready, and then we will start again at 11. So please go have a little comfort break and come back and join us at 11. And otherwise, thank you very much, Tanja, Karuna, and the rest of panel 2. We'll see you later.